These are solutions to assignment 2.18, our first assignment using the definition of derivative. In 5A, you are asked to choose one definition or the other. I will try to quickly do both so that you could check whichever one you happen to use. So our definitions, if I write them, this would be a minus sign. Or f prime of x could be done as the limit. These are both difference quotients as x goes to a of f of x minus f of a over x minus a. And these are both slope formulas. They are both a y2 minus a y1 over an x2 minus an x1 as the 2 points get very close together. So hopefully it sounds a lot like the computer lab you've already worked on. All right, so I need to replace our entire function. So in this definition, first I'm going to put x plus h into each of the x variables in the function. So I'll do this first part with red. So I want to take x plus h and put it into our function. And then for our second, we want to take f of x, and f of x, of course, is the way our function was given. And we are dividing this all by h. If we tried doing our limit right now, if we let h go to 0, then of course our numerator and our denominator would both be 0. So our typical 0 over 0 problem. So we need to do some algebra, and some canceling will probably take place here. So I'm going to expand the binomial squared. And I'm going to distribute the 3. And I'm going to distribute the minus sign. And every single time we do a difference quotient, we'll have some terms that will nicely cancel out x squared minus x squared. And I see a negative 3x and a positive 3x. So notice our only remaining terms each have an x. So they each have an h. And h was our problem, that h going to 0. So if we factor h as a GCF, out of each term that remains in the numerator. Now you can see this canceling solves our 0 over 0 problem, and now we're ready to actually do the limit operator. So now I'm actually ready to let the h term go to 0, and there's only one h term left here, so this is the term that goes to 0 now that I'm ready to do the limit. So what remains is 2x minus 3. So that's the rule of f prime of x. All right, let's see if we get the same thing using the other difference quotient. The only difference is we're going to be working in terms of letting x go to a. So our first step is to do f of x. Again, that's exactly the way the function was given, f of x. And then we're to do f of a. So now let me put a into our two x variables. So f of a would look like the function with x replaced with an a, all divided by the difference x minus a. And now I've done something I don't want you to make that mistake, so I forgot to put my limit operator here. That is essential on every step. And again, notice our problem. If we put a in for x, we would have everything cancel in the numerator and the denominator. So again, we can't do direct substitution. We'd have 0 divided by 0. But if we do some algebra, perhaps we'll be able to factor and cancel for this removable discontinuity. So how can I cancel? Well, can you see that your goal will be to cancel an x minus a from the numerator and the denominator? And factoring by grouping, if I grouped the x squared minus the a squared terms, so the first and the fourth terms, and then the minus 3x, and then notice here we've got minus a negative. So let's make that a plus 3a. So I rearranged them. This is the first and the third term, the second and the fourth. And I did that specifically so that we can factor by grouping. So our first two terms factor as x minus a, x plus a. And that's the first two terms. And our next two terms, we can factor a GCF of negative 3, and that also leaves an x minus a. So now notice that the x minus a term is the GCF of the numerator in our factoring by grouping. So we can pull that x minus a out of the numerator, and from the first term we'll have an x plus a left, and from the second term we'll have a minus 3. And in the future you might be able to skip a step or two along the way, but there's our cancellation. So we no longer have 0 over 0. So now we can actually perform the operation by substituting. Let x become a. So our x term right here is going to become an a term. So we would have a plus a minus 3, and there we get 2a minus 3. Now notice how that compares with our previous result. In the previous method we got a rule of 2x minus 3. Well, 2a minus 3 is exactly the same formula. Here we could just say that this is f prime of a. So whether you're using x or a as your independent variable, you would recognize that you got the same function for both parts of that problem. All right. So let's then take a look at this function here. I graphed it so that we could get used to what we were doing here. So we now found the formula. We're given f of x. So now we found in our previous problem, we now know that the derivative formula is 2x minus 3. And remember what this tells you, the slope of a tangent at any point. So this is the slope of all of the tangent lines at any value of x. And here's a question we're going to come up with now if we use the point 510 as our point of tangency. So this red line is an example of a tangent line to our parabola. All of the tangent lines will have different slopes. And another problem you're going to be asked then is to find the equation of this blue line that is perpendicular to our red tangent line. So a line that is perpendicular to the tangent is called the normal line. So it simply would have the opposite reciprocal slope. Well, we've done the hard work here. So first now we have to find the slope of the tangent at this point of tangency 510. So we know that our formula for f prime is 2x minus 3. So this is our slope of all tangents. So we need to get used to what the derivative formula tells us, the slope of every tangent. So now all we want to do is find out, well, what is the slope of the tangent when x is equal to 5? So we would get a slope of 7. So that's the slope of one specific tangent. That's the slope of this single tangent, not all of them, but at the point of tangency 5, 10. All right, so now we want to write the equation at the point of tangency 5, 10. I've just kind of cut that out of my screen here, sorry. So we simply want to put in our y coordinate and our slope from our derivative. So once we know the derivative formula, we know the slope of the tangent lines. And our last question, which I've kind of cut off the screen here, the slope of the normal at the same point. Well, it has the same point of tangency, so there's nothing to it. The only thing that we have to change is this line is perpendicular to the tangent. So we use the opposite reciprocal slope for the equation of the normal. All right, let's see if we can practice again. So in question 6, you should find the derivative using whichever difference quotient you didn't use in the previous problem. And again, I think I'll see if I can quickly do both definitions of limit. And you need not write the definition first, but I'm going to put it here so that you're all following my substitution. So first I want to take out the x variable and put in x plus h. So in our function 3 times x squared minus 7, so I'm putting in x plus h into the function. And then we're doing f of x. F of x is, of course, exactly the way the function was given. All divided by h. To solve our 0 over 0 problem, we need to do some algebra and some canceling. So I'm going to square the binomial and distribute the 3 at the same time. So our middle term would be 2xh. So I'm going to triple that. Plus 3h squared. And I'm going to distribute the negative sign here. Always be careful about that. If something doesn't cancel, you'll know you made an algebra mistake. And we're always expecting some cancellation here. Positive 3x squared, negative 3x squared. And then we should have, and it looks like I dropped out my negative 7 term here. I better get that back in here. Can I squeeze it back in there? That was my plus 3h squared, and then I dropped the negative 7. So you see what I mean, how if things aren't canceling, you'll go to look to see what your mistake was, what you might have forgotten. So I knew this negative 7 and that positive 7 were going to cancel. How did I know that? Because I know that I need to cancel this h in the denominator. So I knew that every term in the numerator was going to have a GCF of h. So I can take h out of our two terms. And there's our removable discontinuity. Now we no longer have the division, the 0 by 0 problem. So now we're ready to actually do the limit operator. Now we're ready to actually let h turn into 0. So this term, when h becomes 0, this term goes to 0. So what would be left? Our 6x as our derivative of, so this is f prime of our original function 3x squared minus 7. All right, let's try the second difference quotient. By definition, f prime of x could also be computed as the limit as x goes to a of f of x minus f of a divided by x minus a. So first, f of x is exactly the way our function was given, 3x squared minus 7. Now we want to do f with a replacing the x variable. So that would look like 3a squared minus 7. And our denominator is x minus a. So now if you keep track of your goal here, if we let the x's become a's, we'd have 0 over 0. So we know we need to cancel for this removable discontinuity. So think ahead. We want x minus a to be a factor of the numerator. So with our 4 terms, let's rearrange them to set up factoring. Oh, we don't have to factor quite yet. I guess I should take care of my like terms. Negative 7 and subtracting a negative 7 becomes plus 7. Sorry. Let's cancel those like terms first. And now our numerator is set up with just 2 terms. So we can factor the 3 out. And you could, of course, do both of these factoring steps at once. I suspect you already see the factor that's going to cancel. So we've removed the 0 over 0 problem, and now we're ready to do our limit operation. X is going to turn into a. So this x is going to turn into an a as we do the limit. And there we come up with 3 times 2a. And our result this time is not 6x, but 6a. So aren't those algebraically equivalent? So we can say f prime of x is equal to 6x, or would it matter if you said f prime of a is equal to 6a? Of course, those would be equivalent answers. All right, so let's use that formula. And now we want to find, and I need to scroll here. So now in 6a, we would like to find the derivative at the point where x is equal to 2. And we're going to use this as our point of tangency. Well, let's first figure out the y-coordinate there. The point of tangency, I'm going to use our formula and find out what is f of 2. So in our original function, so 3 times 4, 12 minus 7 is 5. So our point of tangency is 2, 5. And our slope at x equals 2 comes from f prime of x, and the formula we just came up with was 6x. So f prime of 2 would give us 12. So this will be the slope of our tangent line. So we're all set then in part C to find that slope. We know the point of tangency, and we know the slope. So some very simple algebra. You can rearrange, by the way, into point-slope formula, but you need not do that. And the slope of the normal is negative 1/12. The normal is perpendicular to the tangent. The point of tangency stays the same. And that's pretty simple, I hope.